So next I'd like to do a little bit of a survey on the modes and applications that are available on the automated AFM platforms. And I'm going to talk about these after introducing the modes in the context of different modules within a fab. So I'll be talking about it with respect to films, lithography, etch, CMP and CMP, and then a little bit of yield management. So there are 6 main modes that are available on the Insight AFP platforms. These are TrueSense. TrueSense is peak force tapping that has been optimized for automated AFM operation. So this is the fundamental feedback way that peak force tapping works is the same for TrueSense. It's just a slightly easier and reduced parameter set to enable greater ease of use for fully automated run. Tapping mode will always have a place in any kind of atomic force microscopy. Tapping mode finds a pretty good application space for automated AFM on larger, flatter structures, such as what we see here with a post-CMP through silicon via. On the right-hand side, we have large area scanning. This is an AFP-specific scan mode. This is not available on the Insight CAP platform. This is large area scanning is generating AFM images over the millimeter to hundreds of millimeter scan areas. So you have AFM resolution in Z while you're able to scan over full die and even larger in some cases. The next 2 modes are probably going to be relatively new to most listeners here. These are critical dimension or CD mode and deep trench or DT mode. These 2 modes are very similar to each other in that they are what we call adaptive scan modes, where they have a very specific step and settle type of scan motion that is different than tapping or TrueSense, which scan at a constant rate. And then lastly, profiling. So single axis profiling, this is available on both the Insight AFP platform and on the Insight CAP platform. This enables, again, millimeters to hundreds of millimeters, single line scans in what's known as a profile. And this has very common applications. Oops, get that little. I got it. I got that one off. The next, excuse me, so starting with films. So films are one of the most important things to measure for roughness, and roughness is one of the key applications for any AFM. In this case here, we are looking at an oxide roughness using our small area roughness application mode and a sharp HPI super sharp probe. And key items that we can see here is 1, the excellent repeatability. We are in the well below the angstrom level for repeatability, 3 sigma for both roughness and average roughness. Chip wear in any kind of application, especially for roughness, is very, very important. And we can see here over the course of 30 images, from image 1 to image 30, we have no chip wear. And this is really noticeable if you look at this little constellation here of grains. You can see there's no change in morphology of those grains over the 30 images. And certainly because we're operating in a fab and we need to have repeatability and reproducibility, it's important to note that the tip-to-tip repeatability is also very repeatable. So we see here on the bottom 3 images here are 3 different probes measuring the same sample, and we can see that they generate the same level of image quality and roughness, RQ, and RA values. Getting into some of the other modules, starting off with lithography. After develop inspection, the different modes that are available on the AFP platform are available or find a lot of uses in the lithography module. Tapping and TrueSense are used for line top roughness, which is a metric that can be used for lithography fidelity. Sidewall roughness has always been a very important metric in lithography, especially looking for standing waves. This is where CD mode can come in and play a critical role in measuring the roughness on the sidewalls. DT mode for resist depth. Resist depth is very important to know how deep the resists are and that the deposition's been correctly applied. Line edge roughness and edge placement error are both critical measurements as well for lithography. Looking at, again, these are both CD mode applications. And then lastly, a final CD mode application and DT mode application would be hybrid metrology. This is a common one where we work closely with other metrology techniques in the fab in a hybrid metrology aspect, looking at resist shrinkage, which is an important metric to know for any design-based models that are being used for feed forward. Etch, this is a very common application for depth metrology in semiconductor and automated AFM. Showing you some interesting and key applications here. Again, DT mode for SGI trench depth or any of the back-end depth applications is very, very key. DT mode for NAND staircase. This is a critical step in the production of NAND flash memory. Some DRAM applications here. This was a pretty interesting one. The high precision control of the CD scanner that's used on the automated AFM with very, very low drift enables us to do what we call down trench scanning. So we're actually scanning down the bottom of a trench and looking at the roughness of the morphology of the bottom of those trenches. We were able to do some, we were able to determine the difference between two different process steps here, between what we call process A and process B, by looking at the trench bottom roughness. And then lastly, another unique kind of an application would be for pillars, looking at the full pillar morphology and profile. So this is, again, a CD mode application where we are looking at pillar height, pillar diameter, top, middle, and bottoms. CMP, this is really the home of large area scanning, profiling, and tapping mode.